Hi again, this is Dr. Faisal Safi, Assistant Professor in Electrical Engineering at this university. In any case, so this time we are going to talk about a special diode, and that special diode is actually the LED. Okay, what is really an LED? An LED is basically a diode, like any other diode, but the only nice thing about it is that it does emit light. So this is the 2-pin regular diode, if you want, a regular LED, light emitting diode. And you can see that one leg is bigger than the other. You can see this leg, and this is the other leg. And this is for a reason, actually. And the reason being is that people, they need to know how to work with this LED. So as you know, that the LED basically is supposed to be in the forward bias, not in the reverse bias. And to know that, we need to know the cathode and the anode, right? So the engineers, they come up with a genius idea. And to do that, basically they made one of the legs of the diode longer than the other. As you can see, one of the legs of the diodes here, of the LED diode, is actually longer than the other one. And that's to distinguish the cathode from the anode. And the convention is that the longer is a plus, basically, and the longer is less. So the longer would be the plus pole, a terminal of the diode, which means it's the anode in this case, okay? And the minus, which is the less, would be the cathode. And then voila, we have basically the configuration of the LED very clear. Now we know which one is the cathode and which one is the anode, and we can play with that. And basically forward bias, it means the current has to go into the anode and out of the cathode, okay? Into the anode, which is this one, sorry again, okay, and out of the cathode. Come again, this is Faisal, Dr. Faisal Safi, okay, electrical engineering professor. As you can see with me here, what you see here, that dark piece is actually the exact shape of the LED device, or the diode device, the LED device, that is inside the package, okay? What you see here is just a reflection of the one of that device there inside, okay? Which is the device itself, which is the LED, the one that generates the light, okay? And as you can see, that piece of diode is actually inside what? Inside this white thing, which is the support, the cage that will support that device mechanically, and that will provide the current from where? From the the current is coming from where? Oops, let's see. Yeah, okay, it should be from the cathode into the anode. Okay, great. So the current is coming from this branch, okay, going there, and then it goes through this tiny golden wire. Let me try to focus again. That golden wire you can see there, okay. Let me try to zoom a bit, change the angle to get some of that wire reflection. You can see that there. We have to change the angle a bit now. Okay, you can see it now. There it goes. Okay, from there down to that dark piece of diode, okay, which is down there, but you can see the reflection of that tiny piece where? In the background there, okay? All right, I'm going to sink a current of just 2 milliamps, as you can see there, 2 milliamps on this diode, and you will see where is the light coming from in that diode. Isn't that exciting? So let me shoot now. Okay, connection is maybe bad a bit, so let me try to push a bit. All right, so good. So let's go back to that picture. See, we are using the lens of the package itself to see this piece. It's very hard to see, actually. You can see that golden wire is going into it, okay, to make the connection. Now, as soon as I shine the light now, see, now there is a couple of reflection, So the one on the top is actually the real device, and you can see the light is coming from the adjacence of that device. You can see the adjacence of the diode. Okay, all right. You can see it's bright in the adjacent side. Okay, which is really neat. Okay, this is the proof of what we have seen in the class. Okay, today. And if you go there inside, you can see this capsule here, this cage, okay, that you see here, the holder, the one on the left here, is actually the one that will just reflect the light out there to the lens to make it propagate in one direction, okay, to focus it. Okay, focus the light. So here again, let's play this game again. Let's see use the optics for our help. Let's see, okay, there's the device through the lens of the package itself. So that's when we shine, and there the light is coming out of the edge, especially that there in the edge, very, very clear there. Okay, and that's where the light is coming from, the diode. Okay, all right. Now this is when you see the top, you can't see a thing there inside because it's oversaturated. Okay, you can see how the light is focused out of the LED. All right, so the LEDs, they come in different colors. This one is a blue color, nice blue color. Okay, bluish. You can see the track of the light being focused to the tip of the package that we used ourselves to have a look into the diode. All right, I hope you had fun with this. I'm sure you will enjoy it when you go home and have a fun learning microelectronics. We have here what we call the LED tester. So the LED tester, basically you can connect here the diode in the first row. The second row is special diode. We are not going to talk about that. So for the first row, it can test basically these regular LEDs, light emitting diodes, and basically you can give them 30 milliamp, 20 milliamp, 10, 5, and 2. We are going to spread them to see the effect of the current on the light intensity that the LED is producing. In class, we said what? We said that by increasing the current that goes inside the photodiode, we can increase the light, okay? And as you can see here, this is the first row is basically, as you can see, the first row should be the anode, and the second is the cathode. That's why we start the long leg on the top and the small leg on the bottom. Okay, that's the cathode, and here goes the anode. Okay, let's put that, and then okay, all right. So as you can see, these LEDs, okay, they are being connected into 3 pins. So you can see the rightmost is 30 milliamp, and this one in the middle about 10 milliamp, and the last one 2 milliamp. And let's see now the light that they emit. Okay, and then bingo. Oops, the connection was not that great. Okay, good. Now they are connected. Okay, let's see. Now they are all emitting light. As you can see, the LED on the rightmost, this one has the brightest light, right? And this one is the middle, and the last one the least. And why? Because the first one has how much? About 30 milliamp going through it. The second one about 10 milliamp, so about 3 times more. You can see the light is much bigger. We cannot measure the light with this device. We need a device to show that even the light intensity is actually 3 times more. But from the figure, maybe it's not easy to get it. Okay. Now the last one to the left here takes about 2 milliamp, as you can see. Okay, let me focus. Okay, 2 milliamp going through the light one, and that's the most dimmed one, dimmed or dimed if you want. It has the least light intensity there, and as you can see, this is proving that the intensity of the LED is proportional to the current that goes through it. I hope you enjoyed this demo, and see you next time. Hi again, this is Dr. Faisal Safi. Welcome back to my short demos. And now we are going to talk about another type of diode. This time, that diode will sense the light instead of emitting the light like in the LEDs, light emitting diode. Okay, for sensing the light, we have 2 types. basically, or actually one type of diode, but we cannot call it 2 times. It's a little bit complicated, but don't worry about that. So the most famous diode that actually does sense the light is it's actually called the photodiode, but when we use it to generate power, we call it a photovoltaic cell or solar cell, okay? And that's what we are going to talk now. Now, this diode works in the forward bias. It's not in the reverse bias like the regular photodiode that we use it in the cameras, in the pixels, you know, CMOS image sensors, for example, and CCDs. So these diode are actually CMOS image sensors, not the photodiode is only in the CMOS image sensors. So the photodiode is actually in the reverse bias, but the solar cell is in the forward bias, okay? I don't have the photodiode, unfortunately, maybe in the next demo. Now what I want to show you is the solar cell, okay? All right, good. So the solar cell basically takes the light, sense the light, by taking the energy from, or basically the interaction of the photons energy with the silicon. The junction will help to separate the generated electron hole pairs, okay, generated by the absorption of the light energy, and then those charges, they move around into the circle. Good. So without further ado, let's see one of them. Okay. So this is one of the available solar cells in the market. Okay, and you can see it's made out of many cells. Why is like that? Because if you imagine, if you have a small battery, if you want to have a significant voltage and current as well, so what you need to do, so basically you have to put each battery on top of each other, and that's why they are like this, okay? So as you can see, this battery gets connected there, and then the other side of the battery goes there to the top, and the back of this goes to the next, and so on and so forth, and then come back and forth, back and forth, back and forth, until you reach the other pole, and then you have 2 poles, okay? So this is typically how the solar cells are made, okay? Good, nice. You can see the reflection of the light, which is my lamps, the lamps of my office, which I'm taking as a lab now. Never mind, that's okay. And on the back here is basically the multimeter. What I'm measuring here is the voltage, basically, as you can see. Let me zoom a bit for you. Okay, let me go back a bit. So as you can see there on the left, let's try to bring it a bit. As you can see, is actually the voltage. Trust me, I'll try to bring this forward. As you can see, the voltage there, it's a volt. You can see DC volt is measuring how much? Is measuring about 228 volt. Now this when the light is shining on the solar cell. Now if I bring this down, okay, down here, facing this, for example, okay, good. I see how much the voltage will get reduced to 0.35 volt, and that's why, because there's still some light going on through the package in here and stuff like that. Still is very small, okay? So as you increase the light, you increase the voltage. Not only that, let's now take this multimeter again and switch that to the current. Let's say this is the scale, okay? This is the current of almost 0 when there is 0.1 amps, okay, right now when there is no light coming to the solar cell. Now observe now when I make that solar cell now reflecting the light that I have there, it has increased, okay, so to 0.15 or 150 milliamps. So at the beginning when there is no light somehow, so it's about 0, maximum is 10 milliamp if you want, 10 milliamp, okay. Now when you shine the light, like now in this case, when you shine the light now, is 150 milliamp. So it's 15 times that initial value because of the light again. And if you take the product and of the voltage and the current, you can see that as you increase the light, you increase also the power that you get, or what we call technically harvest. So as you increase the light intensity of that's coming on the solar cell, you are also increasing what? You are increasing the power that you are collecting from the solar cell, what we call technically the harvested energy, okay? Because we are harvesting the energy from where? From the light that is coming from the sun for free. Now we are paying for this light, but We're talking about the free stuff here, the solar sun. The solar sun. Anyways, the sun actually, of the light of the sun. Okay. All right. Have a good one. I hope that you enjoyed this demo again, and wish you all the best. See you next time. So long.